Hello, welcome to my session. My name is Jay Lee. I'm a principal application architect at Microsoft, and the session today is developing AI apps with Azure AI Services on Azure Container Apps. So my daily job is to help developers build AI application. And Azure is the best place for AI developers. Why? Provide everything from developer tooling. Visual Studio Code is number one tool when it comes to IDE out there, and we provide a different application platform, including Azure Kubernetes Service, Azure Container Apps, Azure App Service, and Function Azure Service called Azure Function. And we provide the various different databases, including SQL Server, PostgreSQL, MariaDB, and the managed Redis as well. And when it comes to AI services, like building AI application, we also provide different AI services. And of course, we provide the end-to-end monitoring solution for application and your platform. Azure AI services. So when it comes to building AI application, model is not enough. You must be using or you must be needing different type of AI services. For example, you need a bot service. So when it comes to building Microsoft Teams AI bot, for example, you need some sort of the integration. Of course, you can do it with the Microsoft Copilot, but if you have pro developer using like Node.js, for example, bot service is there for you. So you as a pro developer, pro code, and can just write a code to integrate with the Microsoft Teams. And AI search, this is actually one of the main topic today, which is to basically store your own data as an index and provide a vector database out of your data. And I will explain in detail in the next slide. And document intelligence. So document intelligence, you can see this is to read from your document, like PDF, PowerPoint, Microsoft Word, you name it. You read it and you store and index it into the vector store. And you can even read the image using the vision model. So this is not my topic today, but this is also one of the most popular AI service among AI developers on Azure. And there are several different services like video indexer, immersive reader, vision, speech, language, decision, you name it. But I don't have enough time to go through every single one of them. So today, out of those services, I will focus on Azure AI Search. So Azure AI Search, when it comes to building the basic AI application, you must be familiar with this pattern called RAG, Retrieval Augmented Generation. So you have data scattered all around in enterprise. You must be having some data in databases. You must be having your data into the files like PDF and PowerPoint stored somewhere in the drive, and you must be using even SharePoint to store those PDF and documentation. And those are all around, and it's not easy to find the relevant data easily. So RAG start from this retrieval system. You must be using the store or vector store to basically index your own data. It could be, again, database, it could be your own file. It first create an index out of it and store into the vector store. And you use the query engine to basically search for your relevant data. And you get all the relevant data, then finally you use LLM like OpenAI to make sense of it. So that user can use their own natural language to ask any questions and get the answer back from the system. Those are the basic idea of RAG. But the biggest challenge when it comes to building RAG system is performance quality. I mean, performance is not really about latency. I mean, it could be latency as well, but the key here is relevancy. So data that you want to search cannot be searched for some reason, for various reasons, and the latency is too slow, or basically, I mean, the rec is not really, giving you the right information. So this is a very common challenge among the AI developers. That's why AI search is the most popular AI service on Azure, because it's really feature-rich vector database, and you can ingest any data type from anywhere, but especially the storage account, you can just easily plug AI search with your storage account and create an index, index out of a box. And if you're using AI Foundry, it has a direct integration with AI search. So you can easily create a connection and use your own data with your model right from the AI Foundry. And it is, again, being one of the most popular service on Azure, and this is battle tested by like S500 enterprises. Retrieving model, I mean, basically finding your data. There are different ways of doing it, and the traditional way of finding your own data is using full text search, like Google back in the day, where they use the text to search for the exact keyword. So you index your the documentation, and you just go through the word and find the exact match, and you use it. That's one of the oldest way of finding information from the documentation. And the vector search, ANN, or vector similarity search. So using the mathematical way to calculate the similarity using vector, cosine vector, then you've retrieve the relevant data. So those are the two different approach. But AI search provides a unique approach called hybrid search. So it's actually making use of BM25, ANN, and LLF at the same time. So this gives you the best result possible. So last year, November, we even introduced two new features. So I will go through that one by one. Before I actually introduce those two features, query engine works like this, right? The steps of level. So first level, the query pre-processing is to understand your intention. So you search for some natural language. Maybe you will do the BM25, or maybe you will do the vector search. Then it retrieve the data from your data source or vector database, from the vector database. And you want to re-rank those things because usually the LLM has a context limit, token limit, so that you cannot just send everything, right? You have to actually just get maybe top 5 relevant information, then send it over to LLM so that you can make sense of it. So those are the basic flow from query to vectorization of your questions, or the BM25, the keyword matching, and do the search on vector store, or do the keyword search. Then you re-rank the result, and you use the LLM to make sense of the data. So we introduced the two new features: rank-tuned L2 ranker and the query rewriting. I'll go through this one by one. So why do you need query rewriting? Because if you're just using the BM25 or vector searching, this might not actually give you all the relevant data, because recently data ingestion in Azure Search as a query, it will try to find just the exact keyword first. And I mean, basically the vector searching doesn't like fully understand the my intention, basically. So that query rewriting is just come up with the different query, like how to ingest data into Azure Search, how to import data into Azure Search, how to add data into Azure Search, so that you can see it comes up with the different query so that it can give you some better result. By not missing any relevant data in the index or vector store. This can be done actually using Spring AI today. So Spring AI provides this thing called rewrite query transformer. You see from the prompt template, it is slightly different from using AI search, because AI search, just giving you the rewrite is as a part of the AI search, but rewrite query transformer is calling LLM again. So using prompt template, as you see, like given a user query, rewrite it to provide better result. It use this system prompt to rewrite your query and come back. And the usage of this is looking like this, using retrieval augmentation advisor. So this is basically doing, advising by using the rewrite query transformer and come up with the better prompt to ask LLM again. The second one, L2 ranker, based on our own benchmark on the real world data sets, this is even better than our old semantic re-ranker. So hybrid L2 new and hybrid L2 old, if you compare the score, L2 new shows a much better result. And you see that re-ranker is not a new concept, has been out there for a while, but we made it even better. So this is announced in November last year, and it is already available today. And this is more faster than the old way, 2.3 times faster ranking. So maybe it's a good time to show you some demo. So let me quickly change to my IDE, which is IntelliJ. So this is my AI search integrated AI apps. Maybe first thing I want to show you is this. I have two different endpoints. The first one is /chat, which is just a normal chat completion. And the second one is chat with data. This is, as you can imagine by looking at name, this is using AI search to find my own information from AI search. So maybe I want to quickly go to my AI search. This AI search, I quickly go to my index. So index I'm using is this one, SharePoint KB index. See, I have around 100 documents or 100 chunks and vector enabled. My index is vector enabled so that it is taking up some space. You can see those are actually the actual information. And this is this is the vector embedding for each chunk of my data. So I want to go back and you see those two endpoints. So maybe I'll quickly show you how this works. So you see the endpoint. I'm invoking chat with data. So maybe I'll start with the question which is totally irrelevant to the data inside my AI search. So which city, the capital city of Korea? Let me ask. And this is returning as, hey, the requested information is not found in the data set, so please try again. Okay, cool. I think this is working as expected. So let me ask a different question. So my AI search has an insurance policy in there. So maybe this time is root canal treatment is covered by my insurance policy. Okay, hope this returns some result. Okay, so it is saying the root canal treatment is covered under my insurance, which is good. So this is under the group dental policy so that, I can, again, my root canal treatment is insured by my policy, which is good. I'm happy with it. So this is cool, right? Using, chat with my own data. But before I move on, I want to show you one more thing. So I'm using the chat extension, like you see. So maybe go to my data source. So this is unique, right? So if you compare the normal chat completion API using AI client versus completion with AI search. So difference is this, right? Set data source. So I go to set data source and I see the extension configuration. This Azure chat extension provides a out-of-box integration with vector store like this. So AI search is the one I'm using. Then there are Cosmos DB, Elasticsearch, MongoDB, and Pinecone. So the difference is instead of using like relying on function calling, maybe I mean, you can easily integrate with those data store, vector store, using just one single method, which is the set data source, right? So I can easily do the bring my own data using AI, Azure AI SDK. Okay, I think I'm done with the AI search. So next topic is pre-CDO. This is the data protection and the identification SDK. And what does it mean by that? I'll go through this one by one. What is pre-CDO? Pre-CDO is production-ready open source de-identification solution. So maybe demo would make you understand better. So if you see the left box, so if you actually send any prompt to LLM, you might accidentally include any PII data. So here on the left, it has name in it. It has also city name in it. Probably not really PII, but that's a sorry, excuse me. My credit card number is there. Even it has my crypto wallet ID in there. It also has my excuse me, phone number. That's my passport number. Those are all PII data. And I'm sure that you don't want to send this over to your LLM. On the right side, so worst case scenario, right? You might actually create or generate your synthetic data to fine tune your model. And your synthetic data might include some PII data in there as well, so that your model is being fine tuned using the PII data, so that accidentally it will expose your own PII data. This is not what you want, right? So CDO comes in here and help to identify the PII data. It doesn't stop there. It analyzes your data and also it normalize your data as well. So this is an example of it. Maybe I'll show you the demo first. So go back to my Bruno. This is my endpoint. So I'll try with this. So hello world, my name is Jane Doe and my number is my phone number, which is a US format. And I call this endpoint, Presidio endpoint. It shows you I have in total 2 suspicious parts. So it shows you the score and entity type recognized as a name, like person, and entity type recognized as a phone number, right? So basically this text has, possibly have 2 PII data in there, and those are score, right? 085 and 075. And by default, right, Presidio support those formats: US driver license, crypto wallet ID, credit card, US social security number, and you name it, right? So those are the supported entities by Presidio, and it anonymizes your data as well. So if I actually send the text again, this time I'm sending it with the result, analyze the result that came in the previous run. I run this. This is the text returned from my Presidio anonymizer. So it actually redacted the name and phone number like this, so that this form, right, this text is safe to be sent over to my LLM, which is cool. Presidio is open source, again, built by Microsoft, and it's being used by a lot of S500 companies. And this is actively maintained by Microsoft, specifically the ISC or the Industry Solution Engineering team for the last 4 years. So you can, safely use it in production. Then you can use it for different multiple purposes. So prompt is one example, also about logs as well. So if you're using like LangFuse, the like log every prompt, coming in and out from LLM, you can use Presidio to redact any PII information in there. And you can even customize or add your own custom recognizer, because I show you, right? The identities that you can recognize is rather limited for now. So if you have your own format, like if you have your own CID format, for example, you can easily plug it into the Presidio. If you have model, that's even better, because you can use your own model to recognize and analyze your PII data using your own model. So those two ways are supported on Presidio today. Great. I'll show you the demo already. So I'll move on to the container apps. So this is my last topic, apps. Now, you use your AI search to build a RAG application. You use the Presidio to secure your application. Now it's time to run your AI apps somewhere. I explained to you in the beginning, Azure has a different app platform, but container apps is latest in this area. Just introduced like 3 years back, so relatively new service. And there's a good reason why it was first introduced, because a lot of customers, a lot of developers are having difficulties to learn and run application on Kubernetes. But this platform, Azure Container Apps, you can use it without having to learn or manage Kubernetes at all. This is basically the serverless container platform. What you need to do is to supply your own container image. The rest of the Kubernetes are handled by Azure. So you don't need to care about like platform upgrade. You don't need to care about creating an ingress, you name it. The volumes, all those things are like handled by serverless platform, which is container apps. Container apps is to run any container image, but we give a very special care for Java. So Java on Azure Container Apps, what you can do is you can deploy your source code without actually even creating the container image. Spring Boot, you can just run one command. It becomes a container and runs on platform today. And it comes with the managed Java component. So if you are using Spring Cloud ecosystem, like config server, Eureka discovery, Spring Boot admin for the administrating the fleet of microservices, those are all coming with the platform. We patch and manage those components for you so that you don't need to manage it by yourself, and you are paying nothing for that. So it's coming with the platform. And it is a serverless platform so that you only pay for use. You only pay for your CPU usage and memory usage, and we don't charge you anything more. And this comes with Kata. Kata is very unique autoscaler. So container autoscaling usually comes with two matrices, which are either CPU or memory. That provides the event-driven way of scaling out your container. So for example, if you're using Redis or if you're using MySQL, so your application is reading from MySQL table, and the table size is growing up, then you can scale out more consumer. So depending on what event-driven technology that you're using, Kafka, like Azure Service Bus, Event Hub, you name it, you can easily scale out and scale in your consumer. You can even scale down to 0 so that you don't need to pay for anything. So those are all automated by Kata. So I'll quickly show you the demo on the Azure Container Apps. So demo, first thing I want to do is to deploy my application. So I run the Azure CLI. It will run for some time. Now, application is deployed. So let's go to my Bruno and test it. This time I'm calling my endpoint from container apps. So let me try to invoke it. Okay, so this is working as expected. And what happens here was I supply, or I just run this command and I specify source as a folder. So it uploads my Spring Boot application to the cloud and build a container out of it and run it on container apps. So that's how easy it is to run any AI or Java application on container apps. Okay, thanks for watching. Thank you.